All right, this is Chapter 1, Lesson 3, Multiply and Divide Monomials. So we're going to go ahead and start. A blank is a number, a variable, or a product of a number and one or more variables. You can use the law of exponents to simplify monomials. So in this first blank, we're going to write monomials. So a monomial is a number, a variable, or a product of a number and one or more variables. All right, so there are a couple of rules that we want to look at when we're talking about powers. So the product of powers rule is actually a really important one. So basically it states that when I have two exponents, so in this case 4 squared and 4 to the 4th, that have the same base, I can add their powers together. I can add the exponents. So in this case, I have 4 squared times 4 to the 4th. So again, 4 squared gives me 4 times 4. 4 to the 4th is 4 times 4 times 4 times 4. So 2 plus 4 gives me 6, 4 to the 6th power. Okay. X cubed times x to the 5th would give me x to the 8th. There are 8 x's. Same thing with 3 squared and 3 to the 4th. There are 6 factors then totals. The factor of 3 is repeated 6 times. Okay. This only works if they have the same base. If they don't have the same base, this doesn't work. You have to, they're two separate things. It's like apples and oranges. Okay? So they have to have the same base. The quotient of powers for any non-zero number a and any integer x and y. Okay? So a can't be 0 because when we divide by 0, bad things happen in math. But basically what happens is if you have two bases that are the same, in this case a, you can subtract their exponents. So if we look at the example, b to the 5th divided by b cubed, they have the same base. Their base is b. So I can subtract their exponents, b to the 5 minus 3, which is b to the 2nd power. Okay, same thing for 5 to the 7th divided by 5 to the 4th. So I have 7 factors, and it's really nice because you could actually write them out. So I have 7 factors on top and 5 to the 4th. I have 4 factors on the bottom. So I can actually go and cross these out. 4 on the bottom, I can cross 4 of the 5s out on top, so I'm left with 3 5s or 5 cubed. All right, so let's go ahead and take a look at some examples. So my first example says simplify using the laws of exponents. So again, the laws of exponents, I have the power property and I have a quotient property. So I have 5 squared times 5. So is this going to be a power property or a quotient property? A power property. So then multiply. So I have 5 squared times 5. Okay. So I have 5 squared times 5, which means I really have 5 times 5 times 5. So I have 3 5s, which is 5 cubed. Number 2 says c cubed times c to the 5th. They have the same base as c, so that means I can just add their exponents together. 3 plus 5 is 8, so I have c to the 8th power. So for number 3, I have negative 3x squared times 4x to the 5th. So what happens here is we have a coefficient out in front of our variable. You want to deal with the coefficients first. Do them like you normally would any other multiplication or division problem. So I have negative 3 times 4. So I want to write this as negative 3 times 4. I have 2 x's times x, and then 5 x's. 1, 2, 3, 4, 5. Negative 3 times 4 gives me 12. And then I have my exponents, x, 2 plus 5. So my final answer is going to be negative 12x to the 7th power. So again, we're using the law of quotients now. So I still have the same base. 4 is my base, and I want to subtract my exponents. 8 minus 2 equals 6, so my answer is going to be 4 to the 6th power, okay? Which is really like saying 4 times 4 times 4 times 4 times 4 times 4. Okay, when I multiply this out, I get 4,096. So in the end, that's my final answer. But the reason we're doing quotients is it's actually allowing you to do things a little bit quicker. So instead of doing 4 to the 8th divided by 4 squared, you just have to do 4 to the 6th power. Number 5 says n to the 9th divided by n to the 4th. Again, they have the same base. Their base is n, so I just have to subtract my exponents. 9 minus 4 gives me 5. So this is really saying n to the 5th power. All right, number 6 gets a little bit more complicated, but we can do it. So I have 2 to the 5th times 3 to the 5th times 5 squared divided by 2 squared times 3 to the 4th times 5. So you could do a couple of different things. You could actually separate them so that you have each of the bases together and then solve each one of those. You could write out all the numbers so they have no exponents at all and then just cross things out. It's completely up to you which way you want to do it. I'll show you both ways. So the first way, let's just write them all out, okay? So this is saying 2 to the 5th is 2, 2, 2, 1, 2, 3, 4, 5, okay? 3 to the 5th, 1, 2, 3, 4, 5, 5 squared, 5, it's 2 5s. I have 2 2's on the bottom, 4 3's, and a 5, okay? So now I can cross out a 2, and a 2, a 2, and a 2, cross out a 3, a 3, a 3, and a 3, and I cross out a 5. So everything on the bottom is gone. I'm left with 3 2's, 1 3, and 1 5. 2 cubed is 8 times 3 times 5. 8 times 3 is 24. 24 times 5 gives me 120. Okay? So that's one way to do it. If you don't want to write out all of these, you can recognize that they have the same base, these have the same base, and these have the same base. So I have 2 to the 5 minus 2, which is 2 cubed, 3 to the 5 minus 4, which is 3, and 5 to the 2 minus 1, which is 5. Okay? So then I have 2 cubed, which is 8. So I get 8 times 3 times 5. 8 times 3 is 24. 24 times 5 still gives me 120. So either way, you'll still get the same answer. All right, so below you have 6 try-it problems. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to go over the try problems, let's go over the answers together. We'll go over each answer and be able to work it out, okay? So let's start with letter A. So letter A says g cubed times g squared. Notice that they both have the same base of g and they're products. So what I need to do is I need to add the exponents together. 3 plus 2 gives me 5. So my answer is g to the 5th power. Letter B says negative 2m times negative 8m to the 5th power. So the first thing I want to do is I want to go ahead. This 5, I need to also put it onto my negative 8. So I have negative 2m times negative 8 to the 5th, m to the 5th. Okay? So I need to solve this first. Negative 8 to the 5th power. Negative 8 to the 5th power is negative 32,768 m to the 5th. So when I multiply negative 2 times negative 32,768, I get 65,536. Okay? And then I have 1 m here and 5 m's here, so I get m to the 6th power. All right, letter C. Letter C says 5 to the 7th divided by 5 to the 4th. Notice that they both have 5s, which means they both have a base of 5. So I can use the quotient rule. The quotient rule, remember, says I can subtract my exponents. So that's what I'm going to do. I'm going to subtract 7 minus 4, which gives me 3. So I'm left with 5 to the 3rd power. Notice that this is a positive, which means since it's not a negative exponent, which we'll be dealing with later, it's always going to be a positive whole number. All right, letter D. Letter D says 12w to the 5th power divided by 2w. So I want to go ahead and deal with the coefficients first. 12 divided by 2 gives me 6. And then w to the 5th divided by w is really like saying w 5 minus 1. And 5 minus 1 is 4. So I get 6w to the 4th power. All right, letter E says 3 to the 4th times 5 squared times 7 to the 5th, all divided by the quantity 3 squared times 5 times 7 cubed. So again, what I want to do is I want to go ahead and separate where my bases are. So let's look at each one of the bases. I have 3 separate bases, 3, 5, and 7. So my first base of 3, I have 3 to the 4th divided by 3 squared, which is really like saying 3 to the 4 minus 2. My second group of bases is 5s. I have 5 squared divided by 5, which is really like saying 5 to the 2 minus 1. My final one is 7 to the 5th divided by 7 cubed. So it's really saying 7 to the 5 minus 3rd power. Okay? When I do this, 3 to the 4 minus 2, 4 minus 2 is 2. 2 minus 1 is 1. 5 minus 3 gives me 2. So I have 3 squared times 5 to the 1st times 7 squared. Well, 3 squared is 9. 5 to the 1st is 5. 7 squared is 49. When I multiply all these together, 9 times 5 gives me 45. So I have 9 times 5 gives me 45, times 49 gives me 2,205. All right, my final try it out problem is F. F states negative 2 to the 5th times 3 to the 4th times 5 to the 7th divided by the quantity negative 2 squared times 3 times 5 to the 4th power. So we're going to go ahead and again separate our bases. So the first base I have is negative 2, which is right here. Okay? Negative 2 to the 5th and negative 2 squared. So negative 2, remember, keep that negative inside the parentheses because that's how it was written in the original problem. Negative 2 to the 5 minus 2nd power. 3 to the 4th divided by 3 gives me 3 to the 4 minus 1 power. 5 to the 7th divided by 5 to the 4th gives me 5 to the 7 minus 4 power. Okay? Now I can simplify. 5 minus 2 gives me 3. 4 minus 1 gives me 3. And 7 minus 4 gives me 3. Negative 2 to the 3rd power. Negative 2 times negative 2 gives me positive 4. Positive 4 times negative 2 gives me a negative 8. 3 times 3 gives me 9. 9 times 3 gives me 27. 5 times 5 gives me 25. 25 times 5 gives me 125. Negative 8 times 27 gives me 216. 15 times 125 gives me 27,000. So that is the end of Chapter 1, Lesson 3.